All right.
Okay. Okay, so let me move this away. So good morning, everyone. Today I'm continuing where we left off last week, where we were discussing the design of this entire proposal. Last week we discussed how bucket provisioning happens. We defined three different actors in this model, the user or admin being one. Cozy is our system, and the backend is the actual object storage backend. Now, the workflow we described was a user or admin requests a bucket, and Cozy uses that information to communicate to the backend and actually create the bucket. We describe the resources that are required. When I say resource, I mean the Kubernetes API types that are used in this workflow. And those were bucket request, bucket class, and a bucket. So last week, after discussing this, we went on to talk about how once we talked about provisioning, we talked about how an application is provided access to this bucket. So I want to continue from that point. So we'll talk about grant access right now. So for granting access, there is a fourth actor involved, and that is the application. So after a user or admin starts a bucket request to create a bucket, the user or admin again requests credentials for an application to consume that bucket. And the way they would do it is they would ask Cozy to provision access for this bucket. Cozy would go talk to the backend and create the credentials or get the access, and then pass it along to the application. The application can then use the credentials to talk to the backend and perform typical object storage operations. So to start out with, let's talk about the first two actors highlighted or selected using this dotted box here. So the interaction between the user and Cozy. The way user would request a bucket is using a bucket access, is by using a bucket access request. A bucket access request, as the name suggests, is a request for access to a bucket. This API type points to a bucket request object, as shown here in the bucket request name. And it also has a bunch of parameters asking for a certain type of access to that bucket, which is encoded in bucket access class. A bucket access class is a grouping of similar type of bucket accesses, and you'll see what that looks like here. So this is the definition of bucket access class, where you specify what kind of policy you want, and every cloud provider we've seen so far, S3, GCS, Azure, and other private cloud vendors for that give object storage as a service, they seem to have a different type of model for policy actions. And the best way we couldn't find a common abstraction, and it doesn't seem likely that it'll be easy to find one. So the method we've gone with here is making policy actions an opaque value passed in through a config map. So that is the field policy actions config map. That map would have the vendor specific representation of the policy actions. And we also have a parameters field here to pass in any additional parameters for the backend to actually provision the access. Say in GCS, there's a project ID, something similar in Azure.
Quick question on this. Why make it a config map at all? Why not just stick it into parameters?
So policy actions is a required field. Parameter is a map string value. And since it's a required field, uh, we have to check for its existence, which I would think qualifies it as a first class field.
So, I mean, wouldn't that happen whenever you provision a volume? The backend would verify that it's there, right? If you stuck it into parameters.
So this is for provisioning access. The whole point of this resource's entire existence is to specify the policy actions. That's kind of how we looked at it, and reasoned about making this a first class field.
Oh,
Yeah.
can I just interrupt? Saad, your question's a good question, and it's one we wrestled with some. What is the philosophy in the Kubernetes APIs when you have a required field, but it's passed through? In other words, Kubernetes isn't going to look at it. Does that automatically mean it shouldn't be a first class field if Kubernetes is not examining it?
Yeah, I mean, the problem is, what does required mean, right? Who is going to validate that? And the problem is that you can't really have Kubernetes do the validation. You need to depend on the backend to do the validation. I think it looks like what you're trying to do is get around that and have Kubernetes have some way to do some sort of validation. The problem is I don't think we can do multi-object validation. So, somebody puts
Oh,
a
that's right.
config map here. All you can do is the field not empty?
Yes.
If not, that's the best validation you can do, and I'm not sure that really buys you that much. At that point, might as well stick it into a parameter and let the backend do the real validation, which it's going to do anyway.
Yeah, it's going to do it anyways. My question here is, as someone writing this spec, not having a policy actions here, what would that communicate? In the sense that if they don't fill in any parameters, what would this bug? I mean, if it's if that field wasn't a first class field, do you think there'll be a possibility that people would create bucket access classes without the policy actions?
I think this is kind of a user experience discoverability question.
Right.
And we've had the same question for storage classes, because what if there are required set of parameters for a storage class? How does the user discover them? Our answer in the past has been that for any given storage provisioner, you need to look at the storage vendor's documentation for figuring out what the parameters are, which ones are required and which ones are optional.
Okay, so if it's already the way we do it, no problems. I think this is very simple to just put into parameters.
Yeah.
There is one other, so there is one other thing, which is keeping it a config map versus just keeping an opaque string. I would still prefer config map, and I believe there's a way to pass in config maps through parameters. The reason is the string that is the representation of bucket access is basically a JSON string. Generally, putting a escape JSON string into this is cumbersome.
Got it. Okay, I can buy that logic. I think I'm fine with that. If you have a parameter that points to a config map, no issues with that.
Okay. Yeah.
Guys, a quick question. For driverless, what happens here? Right? So can you have a bucket access request without a bucket access class, or how does that work?
So the way we've designed it, a bucket access class is expected each time. You have a bucket access class that's a no-op, basically, when you do driverless.
Got it. Okay. So in other words, then I guess my point is then a policy action wouldn't actually necessarily be required in the driverless case, which is another argument for putting it in parameters.
Yep. We'll go with parameters. Oh, just jump a step. Yeah. So yeah, using the bucket access request and the bucket access class, Cozy then figures out, creates copies over the field from those two objects into a bucket access resource. So it takes, I've represented the bucket access request and the bucket access class on the left-hand side. The ones tagged with the green keys are the request fields that I've copied into bucket access, and the orange ones are the access class fields copied here. In the bucket access itself, policy actions config map data. Now that we've decided we will put that as a parameter, I'm not sure if we should leave that as a parameter here in the bucket access or have that as a first class field. I would leave that in the parameters given the recent decision because it would be consistent with the other object. However, that being said, we talked about this where we thought we should copy over the data from the config map into this bucket access object. And the reason being, the config map can change or it might be deleted, and we might end up losing the policy actions if we do not copy this over. Is there a existing philosophy behind that?
No, that makes sense. Once you create a physical object, you should be cut off from you could be cut off from the class object. So everything inside the actual object should have everything that you need without the class object. So if you copy over your parameters, in this case, you'll have your policy as well.
Mm-hmm. So at this point, if you notice the status, so when it creates the bucket access object, the status is set to false. Access has not been granted yet. It's just created this object. And then it goes ahead and uses this bucket access to talk to the backend. It talks to the backend using the gRPC protocol. This protocol has the following parameters, which is the bucket name of the bucket, parameters, as the name suggests, principal. This is the principal that is actually getting the access. I will go into it shortly. Access policy is a separate field because we were modeling it as a separate field there. However, this would go into parameters now because vendor specific implementations would rely on their specific parameters. So I've given an example of what that would look like. So bucket name is a generated bucket name based on the example from last week. Parameters, yeah, we changed it from bucket context to parameters. So this should be parameters, region US East 1. Within that, we'll also have this access policy. I've given an example of an access policy here for read once, write many bucket, where you have access to the first line is a put object access. You can write objects, get object, you can read, but you can't do anything else. So final one is deny. And the response that we expect is the principal, which is the person that got the access, or the service account, or the account workload account that got the access, and credentials, file contents, and credentials file path. The file contents is what would get written into a file inside the applications part, and the file path is the location where it would be written. Okay, so now going into principal, going back one slide. So the principal represents the resource or the workload that's getting the access. Now we need this field to be provided so that we can use this for revoking access, which is the main reason this is needed.
Can we go back? I wanted to understand the file path and what purpose it serves.
So different cloud providers or different object storage providers require the file to be present at different paths. And we need
yes, is this the path in the workload container?
Oh no, we're using a CSI driver that is common across workloads. It doesn't know.
Right, but you're mounting that CSI volume at a particular location. So is this path relative to the root of that volume, or is this an absolute path? If it's an absolute path, it doesn't seem like you're writing the credentials to the volume itself. You must be writing them into the container file system. That's the confusion.
Yeah, so let's think about this. So if I am actually mounting a file, if I know the file, like when I'm creating a volume, I can create a directory path. However, I cannot create a file. So if I'm doing a volume mount from podspec, I can say mounted at this location. But unless I'm doing a config map or a secret, it's not a file that's being pushed into the pod.
But files that you write to that volume will be accessible within that pod, right, with a relative path below the mount point of the volume, right?
Right.
In which case, unless you're stipulating that you're going to mount this volume either at /root or /root.aws, I don't know how you can make that credentials file path work.
Right. So I should have been clearer. So yeah. So this needs to go into the container file system outside of. So okay, here's the issue. So if I have a workload that needs to use AWS's credentials, there's a standard path for having AWS credentials. That is the users home /.aws/credentials. Now that means we'll have to rely on the volume mount to tell us exactly the directory where this file has to go in. That means what I'm saying is the volume mount has to exactly point to some how do I put this, like some directory that contains one of the directories in the chain that contains the credentials file. So you could say /root, then I would put it in .aws/credentials. It could be mounted at /root/.aws, then I would.
So are you expecting the controller to examine the volume mount point plus this credentials file path and then write credentials at the appropriate subdirectory then? That just doesn't seem feasible.
This is an open question, I would say. We need the path either here or in the workload to put the credentials in the right place. Now, current design wise, we went with this so that the workload or the provisioner would tell us where to put it.
I think it's a good question you asked, Andrew. And it's for sure we need, the response needs to contain the credentials. I guess you could think that the sidecar or the CSI node cozy node adapter could then write it to the volume mount that it can get from the pod manifest, right, or the pod itself. So ultimately, these credentials have to live in the container file system in the place where the cloud API, the bucket API or SDK expects to see them, right?
Well, or they have to be a symlink from that to this.
Fair enough. Yes.
Right. Or if the API takes a credentials file command line argument, then you could bubble that up through a command line to point at the credentials file instead of hard coding it to that home directory.
Yeah, that is yes, that is, but we're putting the expectation in the application now.
Well, no, not so. Here's what I'm saying. I'm saying that you are providing credentials to an application. right? So one way you can do that is through environment variables. Another way you can do that is through file-based credentials. The problem is the file-based credentials, where the volume is mounted, all of that is already under control of the workload definition, right? And so I'm saying that in that same workload definition, you should handle the entire thing. You should basically say, this is where my credentials are being written, both because I'm telling you where the volume mount is, and I'm telling you where the file is in that volume mount. And I'm going to pass that file to the command line of the application, or in an environment variable to the application, if the APIs support environment variables. If they don't, and if you go the other route, which is the application is always going to expect it at a particular hard-coded location, I don't know what you do other than automate creation of a symlink, and I don't know how to do that.
Well,
No, the assumption was there's a standard path. However, again, like I think this is something, yes, we can definitely do. Maybe just the credentials file name may be needed. However, even that is not needed. Somehow someone needs to communicate the name of the file, and like you said, it might make more sense for the workload to define that, because that's the one that's going to consume it. The credentials file path is there today just to facilitate that. It doesn't have to be in this gRPC response. It just has to be presented to the system somehow. So,
yeah, I guess part of my concern here is that credentials file path is not a provisioner specific thing. That is a control protocol specific thing, right? There should only be 3 possible values for this, right? If we, you know, or n possible, where n is a small number.
Yeah.
Right. Any S3 control path piece, no matter what the actual backend, no matter what the actual driver, should always say this. So I don't really understand why the driver is returning this information.
So that, you know, the workload doesn't have to. That was the original.
No, I'm saying that you already know that this is an S3 class, so the controller understands this. It knows, hey, for S3, this is where this goes.
You're saying that we'll do that?
I'm saying.
I think
so. We already have this notion.
Give it to the workload. I like this idea of leaving it to the workload. I would rather not have a set of defaults based on the protocol.
Why not?
That's what you're suggesting. So let's say I have a new one coming in. There needs to be a way to pass that in. Let's say they have to override that path. That also has to be added.
So the problem is that how do you make the workload portable? The only way to make the workload portable across multiple different implementations of the same protocol is to have an interface guarantee to that protocol. Here are the things, every workload I can expect, right? I can expect that I'm going to use the following data path protocol, and that with that data path protocol comes an understanding of how I'm going to do authorization communication, right?
Right.
And so
it's always present at a particular path, yes.
Well, I think you can still have that, but there might be utility in having that file at the credentials files path be, you know, like they sent one thing into chat, right? So, you know, if you're using S3, you know, I don't know, if you're using, you know, just putting it in .aws credentials is fine for some applications that are using the AWS SDK, but, you know, one example I gave was the S3 file system client. It wants those credentials to be baked into kind of a different type of file. So I could see, you know, a controller implementation for an S3 dialect might want to present multiple ways of surfacing those credentials as different file types, whether it's just kind of like, you know, a .aws credentials style or a file like a way that's expected of other applications. Does that make sense?
Yeah, you want a way to be able to override it.
Mm-hmm.
I think this is a area where having a cozy CSI adapter is kind of causing messiness in our user interface, because the way that CSI drivers are built is that the user specifies where they want that particular volume to be surfaced, what path they want it to be surfaced.
Right.
Which means our initial version of this, the POC or the alpha, we necessarily are going to have some knob that the user can control that says, I want this to be surfaced at this location. And so we need to incorporate that into our design. But I completely agree with what Andrew is saying, which is we have this concept of protocols within Cozy. Protocols are something that Kubernetes will natively understand. The whole point of having these protocols is that Kubernetes can dictate, here is how I expect to surface them. And for S3, I will expect that they're going to be surfaced at this particular path as this particular way. And that allows a consumer to kind of be agnostic, saying, well, I support the S3 protocol. I will always expect the credentials to show up here. Great. I do like the point that was made that you should be able to override that as a user. So we should have a sane default based on the protocol, and then the user should be able to override that for their workload. The question is, how should I be able to... Go ahead, Andrew.
Finish. I'm sorry. Go ahead. Finish.
No, go for it.
I know one of the other things that's bothering me about this. The root AWS credentials is not a standard, really, even at that level. The API definition is the credentials bit, and maybe even the .aws credentials bit. But you have to imagine that there's going to be workloads that aren't going to be running as the root user.
Right.
And so being able to say where to place this is fundamentally has to be controlled. In other words, I'm saying there's a piece of this that has to be controlled by the workload, because you can't know that. And then there's a piece of this which is dictated by the protocol. And so if the /root piece must come from the workload, and the AWS credentials piece is hard-coded by the data path protocol, then I really don't see how the driver can be passing this back at all. This doesn't make any sense at all, because the driver doesn't even know the first part. And the second part will be the same for all drivers that support the same data path protocol. So yeah. I'm just saying, I think modeling this is a little bit tricky. I mean, there's going to have to be some notion of a relative path where credentials go, and then anchoring that relative path is going to have to be the mount point of the CSI volume.
Yeah, that makes sense. So, even with the default, you won't know what the home user is or home path is. That's what you're saying. Yeah, that makes sense, and yeah, that's really not a big change from where we are at today. I don't know what else to say. This seems valid, and I think we can do it.
Can we agree on a path forward? It sounds like let's remove credential file path from this response.
Have a set of defaults for each of the protocol.
Right, but the set of defaults is relative, like Andrew said.
Right.
And then the root is defined by the user through the mount point.
Yeah, right, exactly, the mount point. Sorry, Jeff, did you want to say something?
Summarizing what Andrew said, and thanks, Andrew, for pointing this out. The workload knows the root path, the root part of the directory, the beginning. The protocol, the claim is the protocol knows, Cozy knows the middle part, the .aws, because we know the protocol. And the last part of the path name is what also in the manifest were you saying, Andrew, the credentials?
So let's just start where you were, which is, yes, the first part is clearly has to be coming from the workload. Now there's some interesting part about the second. So we
Yeah.
believe that there is a convention that this API will look for your home, $home/.aws/credentials, literally credentials, right? So now you've got an interesting problem. Do you want to mount the volume at root AWS, or do you want to mount the volume at root? The problem with mounting the volume at root is there might be other files that are expected below the root user, and so it's not safe to mount it at root, because then anything that the container provides by way of config for other things won't work. And so you might end up having to have the volume mounted at root.aws and have a credentials file that is placed at the root of that volume, right? And so then it might be foo.aws or something like that. And so I'm saying having the freedom to specify, that overlap of is the .aws in the volume or not, I think is an interesting question. But I think that the credentials bit is certainly hard-coded. And so there might end up having to be some sort of path check, like how deep is the volume mount? Does the volume mount include a part of what I expect to be part of my signature? If so, then I only write in the root of the volume or something like that.
Yeah.
So one more thing I think I'd like to add is the ability to override the protocol default. So we're saying something like .aws/credentials is the default for S3. In your storage class, you should be able to override that and say,
the bucket access class, right?
right. And you could even, make that as a subfield of the protocol.
Parameter. Oh, protocol. Okay.
Yeah, because you already have that protocol S3, and then you have some parameters that go underneath it.
Right.
So you could have another
Should that be in
parameter
the
that.
bucket access class, or should that just be in the bucket access request?
So there's two parts to this, right? There's the root, which should be defined by the bucket access request, and then there is the kind of protocol specific suffix of the path, and we have a default for that per protocol. And the override for that, I believe, should live in the bucket class.
Access class.
Let me give the case for why I would argue that it should be maybe in the bucket request. So let's imagine that I have an application that wants to do root AWS, whatever, but it's just not going to be appropriate to mount the volume at that location. But the application is aware of Cozy. And so what it'll do at startup is build a symlink or something dynamically to point to the actual location or something like that. And so we can craft something either as a, what's that called, an init container or something that'll come up and make that symlink for us to the proper location. So I'm saying that the flexibility of mapping this, because at the end of the day, this doesn't change the format of the credentials itself. It's just changing the path. And I guess my point is I don't see how the path to the credentials is in any way a class thing, because that's completely going to be about authoring your workload YAML.
Yeah, I think
if I'm trying to run an application and I need it to be at a different path, just because I'm able to run applications doesn't mean I'm going to be able to make a bucket class, whereas I probably am going to be able to make a bucket access request. So it probably should be in the request, because the developer that's running the application that needs the mapping needs to have the credentials mapped to a specific path is probably not going to be the same person that's able to create a bucket access class. And we don't want to see this like massive proliferation of bucket access classes just because applications need credentials at a different file. At some point, people will start to conform to, if we have a default, right? So people might go, oh, okay, well, Kazi creates it here, and so I'm going to make my application have some sort of like runtime symlinking blah 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 thing or whatever. But Like the reality right now is that most applications are just going to expect the credentials file to be at some given path. And it's a lot easier to change the bucket access request and just update the path than it would be to build a new Docker image with my application that you know what I mean? That, like, I don't know.
Yeah, no, that makes
Yeah.
sense. I think we don't want to end up with a explosion of classes just because, you know, every single application wants it at a different path. I think where I was coming from was we had said we're going to break this path into two pieces,
Mhm.
the prefix and the suffix. The prefix is going to be defined by the workload, and the suffix is going to be defined by the protocol. And so I guess my question is, how likely is it that the suffix is going to, the workload is going to want to change the suffix? Is that something that every application is going to want something different? Or is it?
Here's how I evolved my thinking in real time here.
Mhm.
So this whole question of root AWS or root and then AWS, right? At the end of the day, the workload knows the path that it needs.
Yep.
And so what I'm just saying is it makes sense that the workload control the entire path. It controls that part way by deciding the volume mount point, and part way by deciding the relative path within the volume mount point where the credentials should be written. So if you put both of those in the workload definition, then you just don't have to worry about, the only thing is that the driver is going to know I'm writing a file and here's the contents of the file. You tell me where to write it, and it'll be up to the workload to stage that in the proper location. But that's just two paths, right? One is the volume mount path, which they have to provide, and then the other would just be the offset to that. And we could do magic, or we could just have them explicitly say, "Here's where I want you to put it."
Yeah, no, that makes sense. I agree.
I like the workload defining the entire path, Andrew. But when you talk, but in terms of how do the credentials get into that file? And you said the driver could write to it. And my thinking has been that the cozy node adapter, you know, this thing that the kubelet's waiting for it to call node unpublished volume, that piece of code has the credentials, gets the credentials, and it writes it to the right mount point. But maybe the sidecar should be doing it. I was trying to think of not having the driver do it. I guess the driver would just be passing in the response spec. The driver.
No, I'm not disagreeing with you. I'm not disagreeing with you. That's fine. You get the credentials back in memory, and then you're going to write them to a location. And I'm just saying that location, from the perspective of writing, is actually a relative path. And so we can just take that relative path from the bucket access request. Boom.
Yes.
So given
Yeah, that makes sense. Yeah, having it in the bucket access request, each workload can define wherever they want it.
And there's no security concern with a response containing credentials.
The gRPC response will contain the credentials.
Yes.
I mean, we pass secrets over gRPC in the other direction in other cases. I don't know how you do that otherwise. Well, I know how you do that otherwise, which is you use a different bucket access method than what we've been talking about, which is the credential version, right? The workload identity version is the way you get away from not having to pass.
Right.
That's true. Okay.
So the second thing I wanted to talk about was related to, I think, the pointers. That we started talking about this on Monday.
Yeah.
Talk to that later.
Yeah, I did have something to show for that. Okay. So once the access is granted, the status is updated, and bindings are updated in the bucket object, saying, here we have a binding from this bucket to the bucket access.
Is there a secret created that stores credential information?
In the provisioner namespace, it's created under access secret name, which will be filled in. I should have added that.
Okay, and that's going to be in the provisioner namespace,
Mhm.
not the user's namespace.
No,
If there's credentials that need to come back.
right.
Yeah,
If
I
there are
mean,
credentials.
we're still trying to keep minimum privilege goal, and so the sidecar and the driver don't ever get to go outside of that and out of the provisioner namespace.
Okay, so then in the brownfield case, if the user manually creates a secret, can they configure, what would they do?
I mean, they would create a bucket access that would point to. So okay, so they would create a bucket access which would have the back reference to the bucket access request, and the secret would reside in this bucket access request namespace.
But then your access secret, you don't specify the namespace, right? The assumption is that it's the same as the provisioner?
Yeah. Now, when you bring it up, it makes sense. Yes, this is not something we've. We need a namespace here to figure out which namespace is that. Yes.
Okay, and so then you would have two different modes of operation. If it was dynamically created, you're sticking the secret in the provisioner's namespace, and the namespace here would point to the provisioner's namespace. If it was manually provisioned,
you would
then,
choose where you wanted to put it.
any security concerns around that? If I am a malicious user, I create a bucket access, I can point to any secret in any namespace?
Fair point.
Yeah, why wouldn't the brownfield case, assuming we support brownfield bucket access, which is not something I thought we had talked about to date, but assuming we support brownfield bucket access, why wouldn't you just provision the secret in the provisioner namespace?
I guess user wouldn't have access to that namespace.
Well, that's okay. They don't have access to the bucket access object.
Yeah.
Oh, that's true.
Right.
No, I think you meant driverless use case, where the admin manually creates the bucket access object.
Yeah, in our previous discussion, I was okay with punting on driverless brownfield, or I should say driverless with credentials, right? I was saying driverless in a sort of workload identity class is the thing that made the most sense to me for the bucket access.
Yeah, we can go with that.
Sorry, so the idea is that for brownfield, effectively, we're saying you have to create it in the provisioner's namespace. So all secrets have to be created in the provisioner's namespace. And if you're a user that's trying to do brownfield, you have to have enough permission to be able to create secrets in the provisioner's namespace.
Yeah, I don't like that though.
No, you would just ask for a bucket access request. You would just create a bucket access request. The secret would get created in the provisioner's namespace. A user, even if it's a brownfield case, would request for access using the bucket access request. They would never look at the bucket access object itself.
And
if you as a workload know your bucket and know the credentials to your bucket, this whole system isn't for you. Right? This is only if you've got an admin provisioning the bucket access piece and then a user is asking for requests to that. Right? So this is the normal kind of admin user split. And it just makes sense to put the secrets in there with the bucket access itself. Both of those are in a protected namespace regular users can't get to.
So if I am a user who knows my secret and I have a bucket, I would create a bucket request and a bucket object to represent that. They bind together. I do not have to create a bucket access request and bucket access object is what you're saying?
I'm saying if you're a user who knows your knows your bucket name and knows your credentials for that bucket, that's no longer a portable workload, right? It might as well just hard-coded into your app,
Yeah.
right? The whole thing here is that you could swap out buckets out from underneath. But if you can't do that because you have a fixed set of credentials and a fixed bucket name, right? If you don't have credentials, if you have a sort of workload identity or something like that, and so you're effectively relying on that having been done out of band, that's a different story. But then this whole question of where you put secrets isn't relevant.
I guess the case that I'm thinking about is I do want that portability of if I move this application around and if the bucket doesn't exist, I want it to be dynamically provisioned. But for my initial bootstrap on my initial instance, I already have the bucket manually created. I have the credentials already set up. I just want to get the application bootstrapped. What do I need to do? If I stick everything inside the application and just have it directly, fetch the bucket, then I've kind of hard coded it. I can't swap that out later without modifying my application.
No, I think we're saying that in that case, we can do it using service accounts rather than credentials.
I see.
Well,
so what happens is you have to associate a workload ID with a service account out of band anyways.
Mm-hmm.
We're relying on that. So if we were using service accounts, we would not have to deal with this whole secrets and where we put them.
well, we're saying, Sid, that service account, I'm looking at the BAR, and a service account name or an access secret name are required, but not both.
Yeah.
I don't quite understand that we're relying on a service account name. It says it's optional.
Right.
But I think what Andrew and Sid are saying is that if you're going to do brownfield, your only path is you use a service account. You don't get to.
So, but I said if you're going to do driverless,
Yeah.
then you do service account. Brownfield, if
Uh-huh.
you wanted to support brownfield for bucket access, I'm just saying then that would be like any other static provisioning where an admin has to do the provisioning of all of that. And then you put a request and that request binds to it and you get access to all of it at the binding time.
Yeah.
Yeah, and in that case, you're saying that the secret has to be in the provisioner's namespace, so whoever creates it needs to have access to the provisioner's namespace.
Right, but the bucket access itself is in the provisioner namespace. So the fact that the secret is also there is not.
No,
Oh.
bucket, the proposal is the bucket access instance.
Oh, the bucket access is non-namespaced.
Right.
Okay.
That's
So
correct.
then you have, but for your greenfield cases where you're actually minting bucket access, you're going to use the provisioner namespace to hold those secrets.
Yeah,
Yes.
but for the
Right.
greenfield case, you don't need to have access to that provisioner namespace. All of that is kind of handled under the covers for you by the controllers.
So your concern is that an admin has to now go to two places. One is a non-namespace place and the other is the provisioner namespace for the secrets.
Yeah, but I don't know how valid a concern that is. It just seems a little odd to me, but
Yeah,
I
it's
think maybe
extra
it's just because I haven't
work.
seen that pattern before.
Yeah, it's just because secrets can't be non-namespaced.
Yeah.
Right.
I think that should be okay then. Okay.
Okay. Yeah, that's about it. And then, we update the status in the bucket access request to true. Yeah, and we'll change this to a binary or the Boolean status access granted to true instead of conditions.
Okay.
Then it's given to the application somehow. We talked about that just right now. Yeah, that's about it. And I want to go into this, how the objects work with each other. So we do, so we have on the right-hand side, I've represented all the objects. So a bucket request points to a bucket below it, and then a bucket class on the right. And a bucket points to a bucket access through the bindings, and a bucket access points to a bucket access request, which points to the bucket request. So there is a cycle there So this is really what the list of references looks like.
Yeah, this is where I had kind of a question of, do we end up with pointers back and forth at each other, and what happens if one of these pointers is invalid and pointing off at something else? How do we handle that, and does that potentially cause, you know, data leak issues or anything like that?
So one problem would be if, let's go one by one. So bucket access request, if it's pointing to the wrong bucket request or a non-existent one, there is really no problem there, because we would just not provision a bucket access for that request.
Mm-hmm.
For a bucket request pointing to the wrong bucket class, again, it would be an error condition because we wouldn't be able to use the bucket class.
Mm-hmm.
If it points to the wrong one, that's a user error at that point, because we don't know what's wrong and what's right.
Why is the bucket pointing to the bucket access instead of the other way around?
List of bucket points to a bucket access. It has a list of bindings, so the bucket knows who is using the bucket. In order to be able to delete the bucket, we need to.
I thought that was done based on references by bucket requests.
The references. So if it
You're
were
maintaining two lists, one of bucket requests and one of bucket accesses?
no, there is no list of bucket requests. A bucket request is just a request to create a bucket. At that point, nobody is using that bucket. Like once a bucket is provisioned, nobody's using it.
Well, but if you provision based on a bucket request, then one would expect you would deprovision based on the delete of a bucket request.
Sure, yeah, we would deprovision it based on the delete of a bucket request, but then the references of who is using that bucket resides in the bucket itself. So if I try to delete a bucket by deleting the bucket request, the next step is to go see if the bucket is being used by anyone in the cluster, and if it's not, then sure, I can delete it. Otherwise, you know, it waits on that finalizer for everything to all the accesses to go away.
Okay. So I'm going to say this again. If we front edge provision based on bucket request, not bucket access, then I don't understand how bucket lifecycle isn't entirely a question of bucket and bucket request. Bucket access requests have a dependency on bucket requests. So, you know, that's single directional. So if you maintained that bucket access had a dependency on buckets, I would understand that, because again, it's still nicely layered. But what you've created here is a weird cycle of interdependency, and it just doesn't feel like. Now, if this is solely for the purpose of being really careful about deleting buckets, and you don't want to delete them until all the bucket accesses are gone, then, you know, okay, I guess, but that feels overly restrictive.
No, I understand where you're coming from. How we have to think of a different approach. How would we approach that? How would we ensure that, you know, we don't delete the bucket before all the bucket accesses are gone?
Because if you've lost all of the handles to that bucket, there can't be anybody that's referencing the bucket anyway, right? Or are they solely referencing it by bucket access?
It looks like in this case, they put bucket access request as the way that you reference it in a pod.
Yeah.
Okay.
That's a question as well. Is that the right way of doing it?
Well, the BAR points to a BR, so you can get to the BR if you need it. So we were trying to simplify the pod manifest.
So you've got a leading edge dependency that says you've got to have a bucket request before you can provision bucket access request. That makes perfect sense. So then your bucket gets provisioned, then your bucket access gets provisioned, right? So that would be sort of the ordering of things. And then All right. So the interesting question then is, if I don't delete my bucket access requests, then I haven't deleted a pods handle to this. And all right, so maybe it is okay to have two lists, but I still think then you've got two lists, right? Because I don't think it's safe to delete buckets when your accesses go away alone. I think you also got to make sure your bucket requests have gone.
Yeah, that's how we do it right now. That's how we've thought of it. Right now.
Okay, you don't seem to have a reference from bucket to bucket request. That's the only question then. Right, so if you're maintaining it, at one point there was a list of bucket requests that were maintained. Oh, no, it wasn't a list, was it? Was it just a reference count? Was that the idea? I don't remember what that was.
No, I can't remember. But yeah, that makes sense.
So this is solely a question of finalizer. This is just a question of I don't have any more references to me, I can be deleted.
Right.
It's not that the bucket provisioner in any way interacts with bucket accesses.
Right.
That was my main concern
Right.
looking at
Yep.
that.
Yep.
Hey,
This is
sorry.
probably a question for me.
1 minute warning. I
Okay.
need to drop off at 11, but you guys can continue. I will just stop recording when I drop off.
Okay.
Yeah, I also need to drop too, unfortunately. Sorry.
Yeah.
Okay.
Same.
Thank you, everyone. Thank you, Shing, Andrew, Saad, for and the people on chat, Kyle and Matt, for your
thank you.
questions and participation.
So next step, do we want to like wrap this up at the next meeting?
Yeah.
I
Okay.
feel
Miss some.
if you